p.m. next to the A10 Huawei highway in France. This morning I was in Bordeaux visiting companies, and now I'm here chairing the Optica industry meeting on automotive lighting, and it has one of the most spectacular lineups we had so far. Thank you, everyone. About 300 people registered for the meeting today. Thank you, everyone, for being with us. Let's make the most out of the next 2 hours. Our Optica online industry meetings continue. Thank you for all the feedback so far and for the impressive turnout. Our LiDAR meeting last month had 400 people registered, representing the entire value chain. On Tuesday, November 22nd at 10 a.m. in Rochester and 4 p.m. in Munich, we will start a 2-hour discussion on automotive lighting. There are only a few weeks to go before the CES show in Vegas, and I can't wait. This year, we expect to witness major developments on automotive smart lighting. This is not only to look cool, but also to improve the safety of the driver, passengers, and anyone near the vehicle. Big things have arrived in recent years, such as the use of novel beam steering, next-generation green lighting, 360-degree projection of light around the car, logo illumination to increase branding awareness, and last but not least, the use of micro-optics. Here comes the micro-optics revolution! On November 22nd, we'll bring together some of the major Tier 1 suppliers and OEMs from the US, Asia, and Europe. And in an interactive 2-hour session, they will discuss with our corporate members as well as answer the Optica question. What can they do for you and what can you do for them? Let's talk about LEDs, laser headlights, plastic and glass optics, and their supply chain, from manufacturing to assembly. And in the room, Volvo, Audi, Hella, General Motors, and many more. If you want to listen in and contribute, you will need to register for the Zoom link. And remember, Optica corporate members can always bring one slide to show to the rest. Register now and your company will be part of the supply chain of those presented at the meeting. Remember the date, Tuesday, November 22nd for automotive
And you remember
lighting.
the date, and that's why you are here. The whole idea is to make sure that we understand what the next OEMs and Tier 1 suppliers in automotive need from the rest of the supply chain of photonics. And today we have a great supply chain of photonics. We have companies that manufacture equipment like Besi, like Ficontech. We have companies that manufacture micro-optics, like SUS Micro-Optics, like EVG. We have companies that manufacture laser detectors. The entire supply chain is here. My name is Jose Pozo, and I speak on behalf of Optica. Optica, the big publishing group, Optica, the big individual membership society, Optica, the big corporate member society, now with 400 industry members trying to find ways to work together. I lead a team of experts on the photonic industry, and our job is to find business for you. Here, I would like to share a couple of things with you before we get started. The first one is I always like to start with a bit of an announcement. So just remember that because you are all a corporate member or potential member, we have a board of directors that is telling us what to do. And one thing they told us what to do was to increase the individual membership value by providing market reports. So I have a big announcement for you. We just purchased a market report on the state of the art of the industry in meta surfaces and meta materials for optics and RF modules from Thematis. This market report is now available to all of you. Just remember, all you have to go is to go to this website on the top right corner, and there you can download all the market reports as soon as you're, of course, a corporate member. Please have a look at this market report. We spend time and resources on it, and we are very happy with the final result. It's a long market report, but it will tell you about what it is the next generation micro-optics and meta surfaces for many applications, going from augmented reality all the way to automotive. I also would like to tell you that before we started the meeting, today we have our 4th online industry meeting, automotive lighting. 17th of January is the next one, photonics for medical devices. And Also, we have industry tutorials. On the 1st of December, we talk about peak design. And on the 8th of December, we talk about low loss peaks, companies VBA Photonics and Lion Tech. But also, today, we can announce the online industry meetings for 2023. And we can already tell you that the last Tuesday of every month, we're going to deal with topics such as fiber sensing, QKD, hyperspectral imaging, laser welding, free space optics, biosensing, augmented reality, OLED and micro LEDs, and quantum computing. Remember, these online industry meetings are always to find out what are the needs of the end users. And in addition, we will continue having industry tutorials, and we start the Optica product releases in a couple of weeks. That's going to be exciting. The new products for Optica corporate members being showcased and presented to the entire world, including press and end users. But today is all about automotive lighting. And as I said before, I cannot be happier with the participant list today, and also with the end users and OEMs and tier 1 suppliers that are here with us. Hella, Volvo, Audi, Magna, Huawei, and Plastic Onion. The whole idea is to make sure that we understand your needs. And as usual, this meeting is live streamed in YouTube. So hello, YouTubers of the world. If you have any question, please write in the chat and I will read it in the room. And also, of course, if you want to get in touch with any of the participants, all you have to do is send me an email, jpozo@optica.org, jpozo@optica.org, and I will make the introduction. And remember, of course, you can contact me in LinkedIn or Twitter, and I will, of course, follow you back and make sure that you are part of the industry community. Let's start. And to start today, we wanted to go to one company that has meant a lot in automotive lighting. We go to the company that everybody wants to work with and work for. We go to Hella, and we have from Hella, Daniela Carthouse. Daniela, thank you very much for being with us today. Thank you for kicking off our online industry meeting, Automotive Lighting. The floor and the attention of everyone in the Optica community is yours.
Thank you very much. It's a pleasure to be here today. So I share my screen. Hope everything works. We tested already. So let's start with the topic of today. I talk about diffractive optics in automotive lighting applications. So let's go to the motivation at first. So why do we want to use diffractive optics in automotive applications? So everybody knows the light sources are getting smaller and smaller, and with that we are able to reduce, of course, the size of our optical systems. We want to reduce installation space, as for example, for projection topics, as we can see it in the image with the light carpet. We want to reduce weight, we want to reduce the material consumption. And of course, we have the topic of styling. We want to realize really slim luminous surfaces, really slim light axis surfaces for the headlights. And yeah, for all these motivations, diffractive optics are a solution, of course. And when we look for potential applications where diffractive optics could be used, then we see the topic of diffuser optics, for example. Here you see an image of one of the latest developments at Hella, the so-called flat light, where we have a really thin optical stack, which also includes diffractive optics to generate this really nice homogeneous surfaces with a high efficiency. Then we talk about beam shaping optics. For this, of course, diffractive optics could be used to generate really slim and thin optical designs. And of course, with regard to headlights, we could generate the typical light distributions with diffractive optics. Compensation of color aberration is already well known from imaging optics, but also interesting for us. Projection optics, as I mentioned, with regard to the light carpet topic, and of course, optics for sensors. This is going a little bit too far away from lighting, so I don't want to go too much into detail with this topic, but you see, I think we can enlarge this list. There are so many different applications where we could use diffractive optics for. So why don't we do that already? It sounds really great, it sounds really nice, but where's the point? So we have some challenges, and this is, of course, at first, the usage of LED light sources. No matter whether we use narrowband or broadband light sources, when we use diffractive optics, we already have the topic of dispersion effects. And when we use especially multiple LEDs, and we have to, because we need to fulfill legal requirements, and we have to achieve specific light technical values. So we need to use multiple LEDs, and then we get an effect that you can see here by the two images below. When we use one LEDs, we have really nice signatures with diffractive optics, but when we use multiple LEDs, then we get a blurred image. And this is something that we need to avoid. one point or one possibility is that we use hybrid diffractive refractive optics. There we can take advantage of both worlds, let's say, and avoid some of these effects. But there are also challenges using also this hybrid optics. And this is, for example, the size of our products. When we look at this headlamp, this real light concept, then we see really large luminous surfaces. We see this small, really long signature at the rear of the car. And when we want to simulate these optics, or when we want to transfer the simulated or the design data, then we have really a lot of data and really a lot of sampling points for really the small structures. And this is a topic where we need to find a solution. And the interface itself for the design and simulation tools. And this is something that I want to highlight in this next slide. So when we look for standard tools for diffractive optics, then we have especially wave tracing tools. We have maybe sometimes adapted ray tracing tools. We can just use spherical or plane waves, and we can just simulate the small optical system with the result, for example, diffraction efficiency or intensity distributions of the resulting image. But this is something that is not enough for our simulation tools. So what we need to do is that we find a possibility to combine this with our ray tracing methods, with renderings. We typically use ray files for light source descriptions, and we need to simulate the whole system, the whole lamp, because we want to generate, we want to analyze scattering, stray light, the light technical values that are achieved, and we have to perform photorealistic renderings. And therefore, we need an interface between the worlds of wave optics and ray optics, especially with regard to the design and simulation tools. And this is exactly the point where I'd like to discuss with you today, and where I'm really curious about the feedback from all the participants today. So maybe there's still a solution for that. I'm really interested to hear about it. And that's all from my side. Thanks a lot.
Thank you very much, Anila. Thank you for a great presentation, and thank you for this fantastic slide. You know how it goes, right? Here, I ask you now the key question, which is, what can you do for the others, and what can the others do for you?
So we have already several years experience in diffractive optics. I, by myself, had a research topic on diffractive optics, and we know the background of the automotive applications and know the challenges regarding the integration of diffractive optics. But I'm really interested about solutions, especially for this point, what you see here. So if anybody is in the line to discuss about a kind of interface or combining diffractive and refractive optic tools, so this is the point where I'm really interested in support.
There's a lot of people who, some of them already know you and know you very well. Others, they want to get to know you. So I'm going to go and present a few things to them. The first one is, I'm going to go to the company that made the most impact in micro-optics in my career. I'm going to go to SUS Micro-Optics. Patrick, good afternoon. How are you doing?
Hi, Jose.
It is great to have you here. So just heard the challenge on the table by HELAC, which is a company that I know you know very well. I think there is something here that you can contribute and start having the discussion.
I mean, Daniela is an expert, and we're in constant exchange with our team. So it's amazing to see what they do with the diffractive optics. We do more refractive optics for automotive. So yeah, that's a great collaboration so far.
I think you have something to show us, right?
Yes. So this is what we do. I mean, we're covering many of the things that Daniela showed. We're also doing these projections. We can do these semi-dynamic projections, DMLAs for that. So you see the setup at the top. This is the typical setup: LED, collimator, and a micro lens array. We concentrate on the micro lens array. We can do the simulations for these as well. You see a snapshot of one of these optics here, and we manufacture them on a wafer level, which is very competitive if you go into large volumes, and which then can be used for projection optics, for headlamps, and for interior projections. We have perfect light mixing, color mixing, and you can project on curved surfaces.
Daniela was talking about the different needs for diffractive optics, diffraction efficiencies. Is there anything that you can provide here, added value to the diffractive surfaces, such as the use of coatings? What is the standard process that you use for the diffractive elements? Patrick.
You're asking Daniela or me?
Patrick, yes. SUSS Micro-Optics.
So currently on our refractive optics, we don't use coatings. So they're coating free. For the headlamps, we just had a very interesting simulation done where we can show that we're reaching up to 40% total efficiency of these headlamps, which is amazing for the small volume of these devices. So the volumes, especially in Z direction, are very tiny. You have these small slits, almost invisible, and you still can achieve 40% of efficiency.
Yeah,
and I guess now I will get a question from Paul Henry or from others that are
Paul Henry is also in the
for
room
that
from
for a long
Volvo.
time.
We have a question in the room coming all the way from Synopsys. Ranier Fuedish, what's on your mind?
Yeah, hello, everybody.
Hello.
So for us, it is important to know what is really required between the diffraction optic and geometrical optic, because our business is to provide optical design tools, like simulation software. I'm not sure if Daniela Karthaus is aware, but your company is using our tools already in the method of geometrical ray tracing, but still not the diffraction tool. So we recently started to take a deeper look into diffraction optics in the way that we can fulfill the needs of meta optics and design meta optics as in order to fill the gap between, or let's say in order to produce or to exchange classical optics with diffraction optical element. And it could be useful for imaging optical approaches, but also for illumination optical approaches. And I would like to have maybe an offsite discussion later on, what is really needed and what is maybe not needed, that we can develop our tools in the right direction.
Let's get the scratch the surface first there. Daniela, can you tell us a bit of what is your idea, what is needed when it comes to simulation and design of flat optics?
Yeah, of course. I cannot go too much into detail, but in general, as I mentioned, we know that, for example, kind of adapted ray tracing is already used to simulate diffractive optics, and their standard or regular surface functions, for example, are used as a description for the diffractive optics. And we need something where we could also simulate stochastical optics and the like. So not just regular shapes like, I don't know, gratings or the like. So we need to go more into detail, and we need to find really an interface so that we are able to use the typical analysis tools for our product at the end.
Mm-hmm. So we already have such an interface, and if you want to need more information about this, we could come together and I can speak about this more in detail.
The details, right?
All right. There is something else I want you to know about this meeting. We contacted many people from the industry in the last few days because we wanted to tell them that you were here. And one company that stood out is a company Inoptech. Ralph, Noel, thank you for the exchange of emails yesterday and the day before. Thank you also for joining Optica as a corporate member. It is great to have you. Tell us, what's on your mind?
Yeah, thank you, Jose. And I'm excited to be here for the first time with Optica. I think I was an Optica, an OSA member 15 years ago, but I rejoined basically. So now my question for Daniela, because in your description it says technology scout, and I'm wondering if you are interested also in other technologies rather than, you know, what you just explained. For example, headlight modulation. We are actually quite good in this field. We even work with ex-Hella employees, if I may say so. Yeah, it happens. People leave companies, and then we collect them. Just kidding here. But if I can share my slide very quickly, then you know what I'm talking about. Is that possible?
Yes.
Let's see.
Just remind everyone that Optica members can only show one slide at every Optica industry meeting. Here we are. Yes.
So full screen. Yeah, so just let me very briefly explain what we are doing. As I said, my name is Ralph Noll. I'm the CEO and founder of InOptech, which stands for Innovation, Optics and Technology. We are building vision enhancement systems so that car drivers can be safer and perhaps perform better. So we have 80 patents on various technologies around a whole system. We call it system because it's a combination out of headlamps and electronic smart glasses. The idea is pretty old. It stems from the 60s, but we have taken it to the next level, which means we employ all the high tech which is needed to see better day or night, which is potentially life-saving. So against glare, against a deep standing sun, or at night when the cars come all towards you with the headlamps on. And we can provide basically an anti-glare system. And here in this golden color, you see our slogan, rapid light adaptation and protection, and also contrast enhancement for better safety and performance. So we build modulators for headlamps. So we fire out 100 Hertz light pulses. I don't want to go too deep into this here, just mentioning it. And if you're also into modulating headlamps or any lamp, basically, it doesn't need to be a headlamp. It could be a position lamp, a fog lamp, or any lamp. Then we can modulate it and can ensure that the driver can see everything properly. And of course, it's all in line with the TÜV requirements. We have own light protection so that you cannot accidentally see into your own light. It's compatible with augmented reality and head-up displays and windscreens. We can deliver smart glasses in all sizes and shapes. And we have 10 channels for smaller fleet like Porsche or Tesla. They can come toward each other without interfering. So it's basically clear and glare-free vision day or night. So thank you very much. That was my very brief introduction. And if anybody in the room, even the other companies, see potential, please feel free to contact me.
Thank you very much, Ralph, and thank you for being with us here. Daniela, what do you feel when you see something like this, technology that goes from glasses to headlamps?
I just was wondering whether I've seen a presentation on a well-known automotive conference about that. Is that possible? Have you already presented that at several conferences?
As I said, the idea is actually pretty old, and companies like Valeo, they presented it on CES in, I can't remember the exact date, a couple of years ago. So it comes every now and then, but all these companies have kind of failed to complete the system. It was more like a standalone thing. And we have now patented with 80 patents worldwide, a complete system for day and night. So we took it really to the next level, if you like. But many companies were working on it. Yes, perhaps you have seen something. Yeah.
I think the presentation resonated a bit with the audience because we have a question in the room coming from Selene. Thank you very much, Selene Carrera, for being with us. Tell us, what's on your mind? And remember, you are muted. Selene Carrera? Okay, all right. So the question from Selene Carrera will come later, but in the meantime, I have a question in the chat, which I don't know if I should read now or later, but I will read it. Daniela, for you or for the others? Patients Consulting, Sabir Ramvala, which we all know and admire, is wondering, have lasers been considered as light sources for automotive lighting?
Yes, of course. So several years ago, we already started different tests or prototypes with laser light sources. In general, LED is the main light source currently. So of course, there's the options that in a few years, maybe a laser diode would be a standard for every automotive application. But currently, we would like to combine this typical light source LED also with this, great advantages of diffractive optics. So hopefully, or it would be great to find a solution for that instead of going the more comfortable way and using just the laser light source.
We're going to come back to this topic after many of the speakers later. And of course, we understand that's the future. I think Ralph unmuted himself. Do you want to contribute something?
Yeah, I just wanted to have perhaps an answer from Daniela. Are you also into this field of modulating lamps in a very bespoke way? Is that true, or is that a different partner?
So I'm personally not involved in that topic. But I think we already discussed also internally about something like that. And I will take the topic with me, of course.
Thank you.
Daniela, stay with us because I'm coming back to you a bit later, but we're going to continue with the program now. And we go from one of the key companies in the ecosystem on automotive lighting and to one of the most important automotive OEMs in Europe and the world. I'm a proud owner of a Volvo S60, and it's an honor and pleasure to welcome to the stage Paul Henry Mata from Volvo Cars. Thank you very much for being with us. The floor and the attention of everyone goes to you.
Yes,
Paul
thank you
Henry,
for yes, thank you for introduction. Yeah, so I think you see my screen and my presentation.
Yes, crystal clear.
Yeah. So I will talk about torse hammer only. So I decided to talk about this topic. I could talk about a lot of different topics, but it is my current actuality indeed in Volvo. So in the past, we have released this torse hammer headlamp, I think in 2015 for the first, so the second generation of XC90. On the picture, it is a XC40. And you see that we can do this signature by day, especially in daytime running lamp. And if you go more in detail, so now it is a S90, but you see this light guide technology with a turn indicator and daytime running lamp. And then last week, we have released in Stockholm our new generation of ultimate hammer, which is this design we will see of EX90, which is our XC90, but with only a BEV car. And then if we see what is how is designed this lamp, you can see a lot of components. But what is quite interesting is that we can see that we have this same concept when we are by day and when we are by night. So you can see above, it is a daytime running lamp. And then this lamp will open. And you can see through this daytime running lamp, you have the low beam. And then we have a moving design with a lot of components. And then you can see on the video, I think perhaps you have already seen it. So we have in daytime running lamp, and then we open the hammer, and then we go to low beam, and then we have always the same shape. In daytime and in nighttime, we see the torse hammer design. So what you see is that we have designed this lamp, indeed, with a mechanical concept, with stepper motors. The question I have is quite simple, is that we would like to do it only with digital solution, only with optical system, to be able to have this design by day and by night with the same optics. So is it possible, and how you can support Volvo to be able to do this design in the future? Thank you.
Thank you very much. And there are many people who want to support you in doing this design in the future. The floor is open for questions. If you have any questions or chat, please put it in the chat or raise your hand virtually or physically. Let me remind everyone that you should keep your camera on at all times, because this is not a webinar. It's a group of people who want to work together. And the first person who wants to help you, Paul Henry Mata, is a company from Barcelona, from Spain. The company is Micro Reyeus, and with us is the CEO, Raúl García. Thank you very much for being with us. Tell us, how can you help? Raúl? Yes, you are muted. Let me help you there. You're on mute.
Okay, hello, can you hear me now?
Loud and clear.
Okay, great. Thank you so much. Thank you, Jose, for the introduction. Hello, Paul Henry. Hello, the others. I will share one slide. just to share what we are doing. Can you see it?
Yes.
Yes.
Great. So in microreliefs, what we are doing is we do a femtosecond laser engraving of freeform microstructures, microoptics, or textures on standard production tool or prototypes for automotive lighting parts. So some possibilities, thanks to this engraving in the tool, is spreading or diffusing the light, increasing light intensity, invisible structures for light curtains, and so on. So some benefits: smaller space needed for light guides, more efficiency, low power consumption, innovative signatures, lightweight parts, and so on. So the three ways that we are working in the automotive lighting industry is engraving production tools, microstructuring them, like the example in the Range Rover Sport 2023, where we engrave all the micro optics on the production tool to achieve this homogeneity in the tail lamp. Another example of what we do is microstructuring or texturing prototypes, like the Cupra Tabascan concept, where we engraved thousands of microprisms in the tail parts, in the tail lamp, to achieve this homogeneous light curtain. And the third way where we are working here is to engrave production tools to make textures, which are developed here in microreliefs, for controlled light diffusion. So the idea is to inject transparent PC, transparent PMMA, and to have a controlled light diffusion just because of the texture that we engrave in the production tool, from better homogeneity to better luminance. So that's in general terms what we do in microreliefs to the automotive lighting industry. Thank you so much.
Thank you, Raul. We need to discuss something now, because now I can see that we have three different ways of manufacturing the micro-optics. So first we have SUS Micro-Optics, Patrick, who told us about nano-imprinting lithography and told us about a master and the imprinting. Now we hear you saying that you can do it with femto and picosecond, in this case femtosecond laser. You can actually engrave any structure. We have a third one. I think we have somebody from Femtoprint in the room. Rolando Ferrini, ciao. Thank you very much for joining the meeting all the way from Switzerland. You bring another one to the table. I would like to for you to tell us what is the manufacturing process of Femtoprint, and then I would like to have a discussion with Paul Henry and maybe also with Daniela about what is the ideal manufacturing process.
Hi, Jose. Thank you very much, and thank you, everybody. So Femtoprint, what do we do? We do not print you right into the glass. It's a process which is a combination of laser writing with a femtosecond laser. We create a voxel into the glass where we have, due to the high power in the voxel, we have two photon absorption processes that have different effects on glass. Mainly, it can happen two things. You can fragilize the glass or you can densify the glass. If you densify the glass, then you can make waveguides, which is not relevant for micro-optics. If you fragilize the glass, you make it more sensitive to etching. So afterwards, you do an etching process and you remove the fragilized glass. And like this, you can actually 3D shape glass. You can have micro-optical components. You can have miniaturized optics. The advantage with respect to standard ablation in glass is that we are more gentle with the surface, because with the etching step, we can release all the defects that you usually create with ablation. And on the other hand, which is also interesting, we can do miniaturized optical components, which are in the gray zone of, for example, imprinting processes or injection molding. That's in a nutshell what we do.
Well, Henry, three manufacturing process for optics in automotive. When you hear the three of them, what's on your mind?
Yeah, so indeed, I know the technology from microreliefs, but this technology does not really answer to my question. This technology will improve the homogeneity of this torse hammer, so this is quite good. It is something we are doing already on some project, but my thinking is especially I would like to do this torse hammer in daytime running lamp and in low beam. And then nobody has answered to this question, how we can do it. Yeah.
We're going to try to find an answer to your question, but in the meantime, Patrick has his hand up.
Well, Henry, I would like to have a question on your request. So if you have your torse hammer right now, it's a segmented piece, right?
Yeah.
So how important is the homogeneity of the light distribution from segment to segment for you? Does it need to be perfect? Can you tolerate certain intensity distributions over the torse hammer?
Yes, we can tolerate something. Yeah, but because you are Patrick, SUS Micro Optics, so we know this technology. Also, we know what you have for Lucid, for example. I have dismounted the Lucid lamp yesterday. I think I have seen for low beam 74 watt power consumption. So if I want to do my ultimate hammer with micro optics, I will go to 100 watt for the daytime running lamp, and it is not something I would like to do. I would like to have maximum 15, 20 watts. So we have to investigate with you how we can reduce drastically the power consumption and the optical efficiency of the MLA in this case, if we would like to do this, because MLA would be a solution to be able to do this day and night appearance. Yeah.
Absolutely, and I think combining different manufacturing technologies, as we've seen now, into one component might make it much more attractive from a price perspective and from an efficiency perspective as well.
You know, I love when people come here with a challenge like this on the table. We are not going to finish the meeting until we don't find the challenge for Henry. So all of us stay ready for many hours of meeting. Before that, Eugenie has a question coming all the way from NRC Canada, has a question. I think the question is for Femtoprint. Eugenie, what's on your mind? Eugenie from NRC Canada? I think you are trying to speak and you are muted. Okay, I will read your question. The question is, what surface quality are you able to achieve with a femtosecond laser texturing? Actually, the question is for microregios. What surface quality are you able to achieve with femtosecond laser texturing?
And I was expecting that question, Jose. So with the standard process we have, we are in the order of hundreds to hundreds nanometers average surface roughness, which is not enough for optical applications, but we have developed some surface post-processing with which we can go below 10 nanometers surface quality. We have examples of miniaturized or micro-optical elements with average surface roughness in the order of 5, 6 nanometers. The price to pay is some loss in shape accuracy, but this is being actually optimized day by day by our engineering team.
All right, Rolando, thanks a lot. And Raul, would you like to add something to that? What surface quality can you achieve?
In fact, I have a similar answer than Rolando. We are in the range of 100, 150 nanometers of RA when engraving in steel. And to make something better, we have to use some other processes for polishing that can affect the 3D shape of the microstructures, of course. So it depends on each case.
Let me bring someone to discussion now. We try our best to help Paul Henry with the request. There's a company that many of you know, and I'm very happy to bring to the meeting. I talked to them in the last 24 hours and asking them to be here today. The company is Glowing. Marcel Seeler, thank you very much for being with us this afternoon. I have you muted. You're on mute, Marcel? Marcel, you're on mute. Yes, they are pointing the finger up. That means that they are trying to click unmute. So bottom of the Zoom window, bottom left, there is the mute button. Next to it, there is an arrow up, and then you can select different options for microphone. Marcel, thank you very much for being with us. Can you tell us what Glowing is?
So first, thanks for invitation. A lot of familiar faces here in the room, in the virtual room. We are pretty happy to be here. We have some exciting news. Maybe we can show some slides about it, but I can give you maybe an easy answer, Paul-Henri. So we have the answer to bring MLA to the digital world, and as far as I know, your current model has a combination of this torus hammer that is split into half, and then the DLP is, let's say, coming out of the dark and brings some kind of digital part to the low beam and the high beam, if I'm correct there.
You are correct. Yeah.
So and what we can provide. So we it's been like 12 months now. So we build up a IP for what we call DMLA, so digital MLA technology, and we prepared some optical designs during the last couple of months that can miniaturize small DLP projectors when it comes to ground projection, something like that. So with the small Texas Instruments chips, but also, and this is maybe a good match to your requirement, also for the future headlight generations. And what we can achieve is maybe the next micro-optical revolution when it comes to digitalization. We can reduce the package size down to about 50% or less of a current optical engine of a DLP projector headlight. So if you give me a second, I can share a PDF and give maybe some example.
I want to hear the reaction later about people like Fabulous, Jessica is in the room, or people from SUS, from Accetris, because when you just sell digital MLA, everybody smiles. So I want to know why.
Yes, well, I have to say it's a brand new concept. It's working in the let's say in the virtual world. It's already working pretty well. So in the, let's say, ZMAX world, non-sequential, sequential looks pretty good. It comes without a loss in resolution. It's even vice versa, that you can really resolve the native resolution of the DMD on the street. And we are looking for
show us your PDF. We cannot wait. We cannot wait. Show it.
Yeah. I just want to share the. I have too much monitors here, so give me a second. I have to find the correct PDF here.
After we hear from you, we're gonna go to Lieben from Paranopsin. I want to hear his views about this digital MLA approach.
Yeah. So so maybe to give you just a rough idea how it works. This is the picture of the patent we made. If you're familiar with MLA, you always fight against what is known as ghost images. So you have some image in the center, and then you have some surrounding images. And the idea to bring that to the digital world is to use one of those ghosts as the illumination path. So you hit your DMD under an angle, and if the pixel is in on state, you reflect the light orthogonally, and then the twin neighbor micro-optical channel works as a projection lens. And if you can do that channel by channel, you can do the same trick that we did for the static image MLA like 14 years ago. You can shrink down the volume of any projector. So it's, let's say, it's étendu. It's not dependent on the étendu. So it works for the small DLP chips like 0.2 inch up to 0.55 inch. So let's say from 200 lumens up to we have a design with 1,600 lumens and 160 lux. So you're pretty flexible. It just offers some new degrees of freedom, I would call it. So you can jump from the classic world, call it classic world, that has some limit shown by that black line. You can jump to the green area, and the point where you want to jump to is more or less dependent on the resolution you want to have. If you want to have the same resolution, or maybe you can live with a little less resolution. The less resolution you can accept, the even smaller it can get.
So you with this approach, you have solved the homogeneously problem. Paul Henry, what do you think? Are we in business?
Yes, I think it is promising, but automotive lighting is a small world. So Marcel has all my contacts, so we can do a meeting.
So
you're very welcome. You're very welcome.
A couple of people I want to bring to a table on that.
Give me one more minute.
Yes,
one more minute, because we talked about the static world with SUS micro optics some minutes ago. We have a brand new innovation coming up in about 4 weeks. We start our new module that has an output of 300 lumens for a static image out of a matchbox size package. So very, very compact. fully automotive certified with comparable pricing for static MLA projection. So we can have both. We do static MLA modules in-house, and we do technology for, let's say, next generation digital MLA world. So if there's somebody in the room that has a demand for one or both of them, you're very welcome.
I am, you know, if there was no demand on this room right now, there wouldn't be demand in the world. So I hope there is. Good that Andrei Heiselmeyer from Audi has a question for you. Andrei, what's on your mind?
Yeah, I would have one question. My colleagues were already in contact with Glowing. It's interesting, very interesting. My question would be specifically, do you really own the full DMLA IP, or are you relying on IP from other companies?
So we own the IP.
Mm-hmm. Okay, short answer, but good answer.
Oh, yes, that's the answer you were waiting for. Ralph,
Yeah.
tell us what's on your mind.
Yeah, just a quick idea. I don't know if this is really helpful, but before in Optec and in parallel to in Optec, I'm also an electronics and optics engineer for the past 25 years. And about 20 years ago, we developed, not for the main headlight, but for position lamps and, you know, daylight lamps, a very cheap structure made out of me-scattering transparent objects. We basically dissolved very tiny ceramic particles or polytetrafluoroethylene particles in transparent plastic. And it was nice to see that you do not lose much light, because me-scattering means the light gets a direction. And that worked actually quite well. And we didn't need any laser structuring or surface structuring. Of course, it's a very cheap method, but maybe you want to keep it in the back of your mind. And if you need something into this field, feel free to contact me.
Definitely, we will be contacting you. Before we go to the next speaker, I have two people who I want to be introduced to the room. One of them is a very good friend of mine and a person who's making a difference on the manufacturing of micro-optics as a distributed supply chain in Europe. Her name is Jessica, and she is the CEO of Fabulous. Jessica, what's on your mind?
Oh, yes. I mean, first of all, thank you so much for the speakers and all the attendees. I mean, I love you know, all the possibilities that micro-optics have to offer for the automotive sector. It's really broad and diverse. And I've spoken to Glow also a little bit. I'm so impressed with all their innovative ideas they have. So, of course, you know, with all your design ideas, you know, when companies are looking for these first pilot productions, then be aware that Fabulous is offering a huge network of partners that can do design, origination, replication, tooling, integration, and that we have funding available for European companies. We are also offering the service to US companies. So any company that is looking for micro-optics, you know, please contact me. And I would love to see what we can do for you.
Nano lithography, roll to roll and roll to sheet. She's got funding to get the prototype to series production all the way from Switzerland all over Europe. Jessica, thank you so much for being with us. I want to get a person that has joined Optica recently into the conversation, Lieben from Planopsim. Thank you very much for being with us. We talk about digital MLAs. What do you do? What does Planopsim do?
Hi, thanks, Jose, for the introduction. Yes, so my name is Lieben. About 4 years ago, I founded Planopsim specifically to be a design and software tool provider for nanostructured optics using metasurfaces. So Jose already mentioned briefly an outlook on metasurfaces that's available that I will read with a lot of interest. And I see a lot of very interesting designs today on using microstructures. I would like to have also deeper discussions on how to go still smaller in size to nanostructures where we can manipulate the light, not to replace conventional or micro-optics. I don't think that's a good approach, but rather to introduce additional functionality locally or throughout the whole system, and this can be localized, of course, can be tuned for different dispersive effects, polarization effects. And I think this widens the toolbox a lot compared to what was possible before with refractive or diffractive optics. And I'd be very interested to hear actually, thank you, Jose, the opinion of the room on this. So this is indeed our website. We make a fully cloud deployed or local tool for designing these meta optics and to combine them into your ray tracing modules that you are all using already.
I was planning after one of the next speakers to have a little bit of a debate about where meta lenses are going, but that was the best possible introduction. Indeed, Lieven is going to help all the rest of the Optica members manufacturing meta lenses. And Lieven, I think there is clear room for cooperation with Microregeus, with N2Print, and with SUS. So I hope we can enable this after the meeting. And now we go to Audi. Andre Heinzelmeier, thank you very much for being with us. Tell us how we can help you. The floor and the attention of everyone is yours.
Yes, thank you. Thank you for the introduction, and thank you for hosting this event today. Can you see my presentation?
Not yet, but I'm looking forward to it.
Oh, very good. So I have to
bottom of the Zoom window, share a screen, and then you have to select the window that you want to share with the world. Yes, now you're
there. Now it should work, right?
Yes.
So perfect. Thank you very much. So basically, I brought a few topics from the Audi perspective. What are the end user needs in automotive lighting from our perspective, and maybe we find some interesting topics to continue. I heard quite a few that were already interesting. So basically, let's start. So we are working currently on digital OLED. You all might know we are elaborating that or continuing to also exterior displays to get more out of the OLED technology. So smaller pixels to be able to really communicate. We are of course working on digital daytime running light and DML technology. We heard about the digital MLA technology from glowing. So this is also quite interesting for us. But of course, also the big topic is for us 360-degree ground projection, where we really want to make use of it to communicate and also to introduce the customer in a welcome and goodbye area. And of course, you might know that we are heavily working on digital customer experience with the approaches that we have within my Audi app to really show the potential of our technology. So from a functional needs perspective, we really go for safety. So while driving, we are searching for technologies that really help us to find the optimal light distribution and optimal headlamp performance. But we are also searching for technologies that help us to really target, we have targeted illumination in dark situations while standing. Yeah, you might imagine applications that we are thinking here. And of course, as I said, we are really going for the communication topic for warning others, as you see here indicated on this picture, but also informing others. Of course, we are also going for the comfort topic, and there it might surprise you a little bit. We're really looking for technologies to have the low fatigue light distribution, so a non-tiring light distribution for the driver. And of course, also, as I mentioned, with the ground projection, we are going for welcome and goodbye scenarios really integrated in a customer journey. So highly individual and highly adaptable for customers. And also, we're looking for the optimal illumination of a surrounding in unclear situations. You might know what we do with the gamification approach. You can see here indicated on the left side of the slide. We really want to showcase the potential of lighting technologies with this kind of gamification approaches. This is basically our first adaptation of this, but we also want to offer new functions on a regular basis. Here, the special focus on the whole communication topic. We really want to make the car communicate with people. We also want to integrate it to guarantee a traffic flow. You might also know we have a technology called traffic light information that I was responsible in my former job. This kind of information, we really could communicate to others to guarantee traffic flow. This is a smart city topic. We can talk about it also later. And of course, we want to warn others. See on the bottom side of the picture, we want to use lighting technology to warn people and make the streets a little bit safer. And of course, for automated driving in the future, we really need this kind of interaction with road users to make the whole automated driving topic safer and also better understandable for the customers. And the second big topic for Audi is not just functional view, but Audi is a design brand. Of course, we are working very, very closely with our designers. So we really want to support exterior design with lighting to make exterior design recognizable at night in the front and the rear and on the side. And maybe the community has also good ideas. What are interesting technologies to be able to do this? So we really want that an Audi can be recognized by its light. It was so in the past, and we want to have this also in the future. And exterior light design should also be integrated in the overall design. So we are also looking for technologies in the interior that really can be recognized also. So if you have certain elements in the exterior lighting, we want to recognize them in other places, for example, interior and infotainment. So we're also looking for interesting interior lighting technologies. As I said, individualization is a big topic for us. We want to have a changeable and customizable appearance. We want to be clearly distinguished from competition, and we want to surprise customers with creative offerings during the life cycle. So keep the car fresh and updated. And the last but not least, it's very important for Audi. We have to have this kind of balance between attraction and understatement. We saw a lot of competitors that really have very much light on the car, but we want to be clearly visible, of course, but we want no pure show off and also no light pollution. So this is quite interesting for us. And as you might know, as I said, Audi is a design brand, so it always has to be design compatible. So we have to really think about technologies that can increase our exterior design. So with this, I want to go into the discussion with you. So what maybe the community can offer with regards to the points that I just mentioned. So thank you very much. And my contacts are clear. You can always reach me if you have interesting topics. Thank you.
Words cannot describe how much I love this A6 backlight.
It's awesome.
Just impressive. And I think many of you are going to be at CES in Vegas. I hope that I can see even better things than the ones that we saw 12 months ago. It's just so beautiful. There's many people who want to interact with you. I want to welcome for the first time at these meetings a company that means the world to me because I work a lot with them, Texas Instruments. Peter Laux, thank you very much for being with us. What brings you to this meeting, Peter?
Jose, can you hear me?
Loud and clear.
Very good. So first of all, I'd like to thank you for accepting me as a participant at very short notice. And actually, it was Marcel Silo's suggestion. He pointed me to this great event today, and it's a privilege and pleasure for me to be with this great community today. Thank you.
Thank you for being here. I would like to know what are the challenges that companies like Audi, like Volvo can have and that Texas Instruments can help them with.
So let me give you really a quick 2 minute speech here and share what we have in development or what we promote most actively these days. It's exactly something that Andre just alluded to. It's exterior lighting at its finest, and it goes from what you can do with the headlights, as shown by some of the vehicles of the Audi brand as well, up to projections more in the proximity of the vehicle. And exactly as indicated here, there's a great variety of options or projection solutions that we can support for both sort of a vehicle orchestration, which has a more impressive customer appeal, as well as to improve the safety. And when we talk about safety and use cases like this, we have things in mind like projecting warnings for the most vulnerable road or traffic participants like pedestrians or cyclists, particularly at nighttime where most of the fatal accidents happen, as we have heard in many of those industry meetings and conferences just in the recent past. So our technology provides a solution that is programmable. It can show animated or video content, which gives you a lot of flexibility to have this sort of dual use application that combines the safety use case with a more sophisticated vehicle personalization and welcome scenarios for individual customers or for fleet customers. And here we have a lot of different possible applications that can be installed as a small light replacement just with power and ground provided to the module, or you have something that supports live video stream, and the way in the middle would be to have an instant on operating tiny little module and that is in vehicle reprogrammable. And maybe I share something with you that I'm sort of proud with, and I guess Andre and a lot of others know that that module or that example pretty well. Let me flip through here real quick. So this is actually Wolfgang Huhn's vehicle, who got a replacement module that just he took off the static projector and did plug in a module that shows a video with one of his favorite leisure time activities. And this is what he was able to share with a few of people in the community. And that's just an example of what you can do with it in its simplest way, taking one module out and plugging another one in. So that is what I'd like to share with the community today, and stop here. And
let me also take the chance to say hello to Dr. Han and Dr. Freddy from DBN. They are doing a fantastic job. I know they are watching. So great to have you here with us. And DBN is doing a fantastic job on this. Peter, it is not only about making it more beautiful. Do you see any applications on this floor lighting that could make the car safer?
Yeah, so what we see, and or actually already a couple of tier ones have used the recent industry events to show their ideas, combining indication like turn indicator with projection solutions to make that better visible, make it visible more in advance, to give folks outside of the vehicle an idea about what is the vehicle about to do next. So it's more like projecting the intent of the vehicle, particularly at nighttime. It's all agreed it's not visible that well at daytime, but particularly in challenging situations and in the areas where it makes the most sense, it can enhance the exterior lighting of a vehicle in a great way, on top of the personalization or individualization capabilities that come literally for free if you use it that way.
Andre, you talk a lot about communication, communication between cars using visible light. Do you have any specs on the bandwidth that is going to be demanded, or on the wavelength that is going to be used, or anything that can help us start drafting the design for some transceivers for you?
No, currently we are investigating basically what do we want to communicate. So we're breaking it really down into use cases, yeah. And then we have our OLED technology and our OLED roadmap to really have where do we show what and in what time frame can we communicate what. But the first step is to really think about what do we want to communicate, because we don't want to communicate everything. This, as I said, it really has to match also our design, and we are currently investigating together with our partners what is exactly to be communicated on an Audi and what not. So this is the current challenge.
You were the one that brought the light carpet to the world, and I loved it. And now I can see that you can also have video carpet, thanks to Peter. So, and this is becoming
Yes,
very, very
true.
exciting.
Yes, absolutely.
Andre, and also Jeremy from Magna. I'm gonna introduce you a couple of people because there are people who want to come to the meeting to interact with you. First, I'm gonna go to a company called not anymore called Balsers, a company called Materion Precision Optics. Guglielmo, thank you very much for being with us today. A couple of times during the meeting, we already addressed the topic of coatings, thin film, and next generation optical elements for automotive. I would like to know what Materion brings to the table today.
Okay, thank you, Jose, for inviting me to this event. It's very interesting for our company as a supplier of coated optical components to see what the industry's needs are, especially from the OEMs to the integrators to the tier ones. If you allow, I would like to share just a few slides to show the community what our company offers.
Let me remind everyone that Optica members can only bring one slide at these meetings, and the purpose of this meeting is for them to connect with the end users. So please go ahead. By the way, I am very impressed with what Materion is doing in the film in the thin film technology and many other applications. And today we're going to hear
Tell
about
me
automotive.
if you see my screen.
Crystal clear, beautiful bird.
Okay, so as you see on the slides,
you can go to presentation show slideshow mode, bottom left of the yes.
Okay. Okay, so we offer beside of optical coated components for the automotive lighting applications, also optical components for head-up display, digital instrument cluster, and LiDARs. Here you see an overview of the area. So headlights is clearly also one of the applications. And what we offer are especially coatings on polymers, but also on glass whenever they are needed to make the applications and the products that we have seen and applications we've discussed before. Let me switch to a second slide just to give you a rough idea what this means. So we offer patterned chrome coatings. We also, on the illumination part, we can offer static phosphor components for illuminations. Patterned chrome, as said, for welcome lights are in use with our products. And so this is, let's say, in very short, what our company offers for the applications we have seen today. And just to remind all of you, if you surf on our webpage, you find a lot of dedicated materials, brochures, where you find our complete product portfolio for the automotive industry and especially for the automotive lighting applications.
So, Paul, Henry, Jeremy, Andre, can you challenge, please, Materion, on what are the main needs for coating? I'm going to go first to Andre. When it comes to optical elements in automotive, what is the biggest challenge that can be solved with coatings, with thin film technology on the optics?
Hey, can you hear me?
Yes.
Yeah. Okay. I'm already unmuted. So you mean with coatings in general, or?
Yeah.
So specifically, I would say to have the coatings, we are looking for really to have very, very slim lines. Yeah. So you might also be able to help us with this regard. So maybe we can have a chat and a meeting about this to talk about this.
Okay, let me also go to, let's go to Magna now. Let's go to Jeremy, because we want to bring you to the table. Jeremy, it is your first time at this kind of setting. I hope so far you have enjoyed the experience. It is, as you can see, a very interactive meeting. The floor and the attention of everyone goes to one of the main important tier 1 suppliers in the automotive industry worldwide, goes to Magna. Magna Lighting. Jeremy, the floor is yours.
Hi. Yeah, thanks for having me. My my report is not as colorful as the other ones I've seen since it's my first time. I didn't really know what to expect. But so I'll go ahead and share my screen now. So with this
Bottom
one,
of the Zoom window, there is a share screen button in green, and there you go.
you see presentation, right?
Yes.
Good. Okay. Yeah, so thanks again for having me. The report is a little on the bland side. I apologize for that. But this kind of goes in line with a couple problems I have on here. It goes in line with what we've been talking about, with especially with micro optics and films. So I'll proceed with what I have, and we can touch on those. So the one problem I see in the industry is the RAW files for simulations are very large in file size. And sorry, it's not going. There we go. For example, a common RAW file with only 1 million rays is about 27 megabytes, which isn't that big of a deal. Except when you amplify that over, they go up with a proportional with quantity of rays in the file size. So for example, you're going to be at a gigabyte with 40 million rays. And to put that in perspective, for a good quality lit rendering and for uniformity for appearance of the lit function or a rendering of the body style, you need like billions of rays. And so it just amplifies this here at like 27 terabytes if you run it with an actual RAW file. And that's just not practical by any means. And so the common workaround we have is to use a fake light source, like an emitting disk, for example, something that would mimic the size of the LED emitting surface. It's a very common practice, but the problem is that it lacks accuracy. If it's not completely Lambertian, if it's close, it might be off a little bit. If it had like a notch in the corner of the LED, for example, there's some variations in there that have a negative impact for intensity of the performance of the pattern, especially if it's like a low beam system for a very specific pattern, or for appearance. We see that in the renderings of these products also. And so the goal I'm asking for is, example would be for light source manufacturers to work with in a perfect scenario, the light source manufacturer would work with the optical software manufacturer to create these accurate RAW files, to reduce the file size and still allow us to run these billions of arrays in a quicker manner too. So it's either that, or option B is what other ideas from the group that people would have to kind of circumvent this issue that we've seen. So that's the first one I have. I'll keep going. The second problem I have seen common is characterizing material properties in a timely manner. They're very sensitive and accuracy is questionable when we get these. And this applies also to the films and micro optics that we've been talking about. So, oops, sorry, that wasn't supposed to happen. Oh well. Characterizing materials example include refractive or reflective components, diffraction, anything that bends the light really. Texture, graining patterns are very common. Surface roughness, that would apply to tooling, for example. Surface colors, if it's white versus gray versus black, there's differences in specular versus scatter of those properties naturally. If it's a volume scattering material, like a diffusive material that we've been seeing come to market, I know it's more popular in the European market, but it's very seldom in the US market. And basically anything else that refracts or reflects light in a mostly random pattern, including micro optics. Micro optics maybe not be a random pattern, but they're very small and there's a lot of optics in there. So the more elements, we have to add these into our simulation software, and those take time also. So with micro optics, we try to streamline those using a characterized material. Questionable result examples include finding the correct balance of specular versus scatter. If it's an A side versus a B side of a translucent component, those materials would apply differently. They would be, they would be maybe characterized the same way, but applied differently. And that's a concern. Different materials, and if it's an anisotropic pattern, especially. So the current time in the process we do is we retrieve an actual sample, whether it's a textured plaque, a colored plaque, a micro optics plaque, any kind of sample, we would need that. And then we have it scanned, we can send it out. And these would take about 4 to 6 weeks, really depends. Populate on the software, confirm the accuracy. And it takes some time. Each step has its own list of concerns for time and accuracy. And so it's a delicate system. We can confirm the accuracy in a controlled environment. It takes a little bit of time and you need to make sure you're doing it right in the lab. But applying a single result to any condition, it does lack accuracy and creates questions. So there's always concerns with that. So my goal here, example would be to develop a streamlined process for characterizing the different materials and finishes with trusting results. And again, or looking for ideas, experience from the group that they'd be willing to share with how to get these into a better process, really. So thank you.
Thank you very much. For the first time, you knew what the meeting was about, because you tell us exactly what we wanted to hear from you. What are the challenges and what are the goals, or how can we help you? There's a few people that they want to introduce you. The first one is from a company called Laser Lamps. Ben Russell, thank you very much for being with us today. I would like to ask you, Ben, what brought you to this meeting, and is there any room for cooperation you see already with Magna or the others?
Yeah, but thank you very much for having me. It's the first time in this call. Yeah, I mean, we're a aftermarket lighting specialist. We manufacture and design the products here in the UK. So yeah, to be honest, it's the first time I'm hearing some of these interesting points, and there are definitely some good ideas coming. But yeah, I'm probably more of a spectator today, Jose.
So I have a few questions for Laser Lamps that are being texted right now to me anonymously. So the first one is Laser Lamps. So you are focusing on LEDs. What are the wavelengths that you are mostly targeting, and what is the future for laser lamps? Are you going into laser lighting as well?
So I mean, we're certainly interested by laser technology. So yeah, we've been trialing some of the components that are on the market, but to be honest, at the moment, it's not well, it's not delivering the required level of performance versus the sort of power consumption for us, for our customers. So, and as well, we're not satisfied on some of these chips that we've been testing about the color rendering and so on. So yeah, for us, we're still very focused on LED. Yeah, the name Laser Lamps is, let's say, going back 12 years when I founded the company. So at that time, it wasn't particularly planning for the next generation technology. But yeah, we're LED focused. But yeah, all of our products are using, let's say, normal LED technology you would expect to see in automotive.
Thank you very much, Ben, for being with us. I'm going to come back to you later in the discussion. But Jeremy, there is a question for you coming all the way from Alexandre Fong. Alexandre, join us and tell us what's on your mind. Alexandre Fong, I think you're muted. I will read Alexandre's question because I think he's muted. Alexandre is wondering, have you used any imaging photometers?
Yes. Yeah, we use those on a regular basis. They're very important for comparing what we do in a simulation versus the actual part.
I would like to ask you, because so far we have been seeing quite a lot of design of optics in the room. Is there any particular challenge that you have for them? Any particular question that you have for them? And then afterwards, I'm going to give the floor to Kimoto, and I'm going to give the floor also to Chef Lab, to Luca. Jeremy, tell us, what is the big challenge there, optical design?
The trending is going towards the micro optics in general. Of course, they have a lot of benefits with that. Thor hammer, for example, you know, they would be ideal for a uniform DRL, right? There would be concerns putting those same optics on below beam because it would diffuse the pattern. But is it possible? That's definitely needs to be studied. I like the concept, it's great. But micro optics in general, those are the concern for design for manufacturing, for example. We need to find these manufacturing facilities that do this process in a accurate manner. And then everything we do is in pretty much injection molded plastic. So we need to make sure that we have the right shrinkage of the materials, the right surface finishes, and everything else. All that applies, all the design for manufacturing and assembly conditions go into our designs, and we need to simulate those. Simulating accuracy is probably one of the biggest hurdles.
Later on, we're going to have Plastic Omnium on the stage. For me, one of the bigger questions, and we have had this discussion in the past quite a lot, is are we going towards plastic or towards glass for automotive lighting? And what I hear between the lines from you, from Magna, from you, Jeremy, is that plastic is the material of choice for most, if not all, the...
Yeah. Yeah, glass does have its benefits, but it's also heavy and more expensive. But the optical grade and the reliability with it, it's more controllable in some cases than the plastic would be. So there's pros and cons with it. But
Jeremy,
yes.
There is a company that I want you to meet. The company is called Kimoto. Tell me the truth. Have you heard of Kimoto before?
Kimoto?
Yes, Kimoto. Christoph,
no.
What is Kimoto?
Thank you for the invitation, Jose. So basically, Kimoto, we are a Japanese company. We are working in coating plastic films. We are mainly used like in terms of lighting in the interior of cars. If we're talking automotive, in display systems, interior lighting, also like touch screens. So like user interface integration. A big topic for us at the moment is like combination between lighting and the interior, let's say touch screens, everything connected to this, doing hard coatings, doing light diffusion. So that's one topic that Jeremy mentions. So for example, we supply also BSDF profiles for our materials for simulation for different software packages. So that's certainly something that can help the designers to actually simulate before doing any prototyping. So light diffusion, light absorption. So these are the things really connected to optics and lighting that we provide to the market.
And you work mostly, if not all, in plastic optics.
So all our materials are based on different plastics like PET, polycarbonates, PMMA, combinations thereof. So it really depends on the applications. One trend we see a lot, especially on the design side, is the going from the display industry, going from a flat display to a three-dimensional display. So formable materials like formable diffusers with good, let's say, good optical properties. This is very important for our customers at the moment.
Jeremy, when you hear a company focus on making thin film technology and coatings for plastic optics, of course you get excited because that's what you need. So what kind of things come to your mind?
Yeah, no, I think it's great. I do like these. The way technology is going, yeah, along with the micro optics is the films. They're definitely trending. Something I would like to learn more about it for sure. Some concerns I have would be make sure that it's environmentally stable for the automotive exterior lighting. There's a lot of accelerated environmental testing we have to go through for moisture and heat and all that, and make sure that it's going to adhere to the plastic over the life of the vehicle. Yeah, I would definitely like to learn more about that and see how we can include these in our designs.
If something happened between the two of you, I really would like that you come to the next meeting and you show us something, because this is, for me, before the meeting, we try our best to match the interests and unique selling points of companies, and that was a clear match there. There's another one, Jeremy, the company Chevlab. Luca is here with us. Chevlab, thank you very much, Luca, for being with us. Can you tell us what you do in terms of design and what kind of things you could do to contribute to Magna and the others?
Well, thank you for the invitation. And so Chevlab is a company which provides support, engineering support for designing optics, mainly in the automotive sector. So we design rear lamps and headlamps for motor, but also auto as well. And well, I found the Magna presentation very interesting because we have almost the same problems about verifiers and simulations. I'm an optical engineer, so I focus on the design of the optics. And so The main challenge now maybe is about obtain homogeneity of the light function, and so we will always need more rays for the simulation and to get a good comparison between the simulation results. Yeah, so.
Yeah, it's definitely a common trend. I've seen this for a long time in a couple of companies, and problem's not going away. So that's why I'd like to bring it up and see what we can do as a group, as an industry to fix this.
Patrick, from SUS, what's on your mind?
I think, Jeremy, we really need to talk about this. We have a great team here of optical design engineers. We have homemade software, and we have all the understanding of the processing as well, and the metrology. So it's not only the process parameters, it's also how you measure it, how you feed that back into the manufacturing loop and into the designs. So it would be great to have an exchange here between you, our design team, and yeah, look forward how we can help each other.
Good. I do recommend that you make this kind of link, because so far, well, SUS has been great with all the introduction we have made. Thank you very much, Patrick.
Yeah.
Jeremy, I travel a lot, too much. That's what my wife says. I don't stop I always go one place to another. And a few weeks ago, I was in Jena, the capital of optics in Europe. And I met somebody from Huawei in Jena. That he was from Spain. And he's leading now the R&D of automotive lighting in a new Huawei center based in Jena, and trying to connect the entire supply chain in what we call the capital of optics in Europe. Thank you very much, Fernando, for being with us. Buenas tardes. Tell us what you're doing, and most important, tell us how we can help you do it better. The floor and the attention of everyone is yours.
Thank you, Jose. Let me share my screen. Can you see my screen?
Yeah, I see myself now.
Now I think it's
yes,
running. Okay, thank you very much for the introduction. So you have avoided to explain why we are in Jena. So, but well, what I want to show is well, some ideas of what is the dream of and the work Huawei wants to do in this world of automotive lighting. Let me start with this phrase, the mission and vision, that is bring digital to every person, home, and organization for a fully connected, intelligent world. So Huawei hopes to bring its decades of ICT expertise to the automotive industry as a provider of new components for intelligent connected vehicles. As vehicles become more electric and intelligent, Huawei wants to help car makers to build better vehicles. So Huawei is offering solutions to some needs that the lighting industry is demanding, like issues of safety impairment due to glare, the lack of driving interaction, or the demand of personalized and added value experience. We identify three functional pillars. First, smart lighting, that is dedicated to the automatic adjustment of light performance based on road conditions. The second is driving assistance, looking into the custom interaction settings, making that your car better understand you. And finally, interactive entertainment that offer high definition pictures, allowing a unique visual experience. So we have identified 6 different applications scenario I will show you right now. First is about improving the safety for drivers and other road users by increasing the low beam. So enlarging the range of the beam, and improving the illumination and homogeneity. So especially in urban or country roads, illuminating the way ahead is key for driving safety. Also for adaptive driving beam will enhance the visibility with multiple cut areas with variation in size and intensity. Other topic is about these narrow lanes that are guiding you in special difficult areas, avoiding that you invade other lanes. Also, we can see that there are synergy between projection display systems, and the evolution is toward communications, like projecting information onto the road. Vehicles will interact with environment through dynamic projection, the so-called light carpets, illuminating the surroundings areas outside the car. And also the high-resolution headlights can display sharp symbols, lines, or figures directly on the road in front of the car and close to the point of interest area of the driver. So the displayed information varies from vehicle to vehicle, distant alerts, or animated greetings, for example. Also, we have to think that vehicles are quickly becoming the third living space for people after their home or workplace. So this is why user demand for visual experience on the go has been increasing. Users expect immersive experiences that deliver images and video with higher resolution and broader views. So the developments of related to digitalization of cars lead to new approaches to safety, comfort, and information services. So the evolution of technology and applications is bringing more complex systems, more components, and sub-assembly. And implementing these advanced front lighting systems, including intelligent lighting, process sensing, fast computer, and software control, has to be standardized, and a platform and architecture is needed. And that's why Huawei Intelligent Automotive Solution is the global platform that integrates intelligent digital platforms powered by emergency technologies like 5G, cloud, etc., and optical technologies that will connect the physical and digital world for vehicles. During these years, Huawei has demonstrated to be strong in developing complex optical system and architectures. So Huawei is bringing cutting-edge technologies to empower the optical intelligent vehicles. We can see that the optical connectivity allows high bandwidth, lightweight, sensitivity to electromagnetic interference, even low cost. In-vehicle optical technologies offer a richer immersive experience and also are an intuitive tool for vehicle driver interaction that improve driving safety. And finally, automotive lighting is becoming one potential critical node from intelligent lighting, because lighting systems could represent a key location for integrating sensors such as local cameras, radar, and LiDAR with the most advanced projection and illumination systems. Intelligent vehicles are the product of multiple industries built on integration of core optical and digital technologies with traditional mechanical technologies. Huawei Intelligent Head Solution is also implementing 3 modules: the Intelligent Light Module, the LED driving module, and the headlamp control module into the headlamp assembly. These last ones are highly integrated systems using serial bus and communication protocols to connect intelligence devices for real-time control applications. And the Intelligent Light Module is the core of the optics and the light controls. So summarizing, we see that with the new digital headlight technologies, light distributions will be reinvented. High resolution combined with flexible software and sensor integration open up options that were inconceivable before. Thank you.
Thank you very much, Fernando. Thank you for a great presentation. I honestly, I had bets with some people in the room of how much you would be willing to share in a meeting like this. And to be honest, you have gone beyond our expectations. So thank you very much for that. There is a lot of topics I would like to address with you, but I think we already have a few questions in the chat. All right, so the first one is coming from okay, it's anonymous. So when it comes to 3D sensing, what kind of approach and what kind of wavelengths and technologies you would like to explore? And they say that you could tell us a bit more about this.
About 3D sensing?
Yes.
Well, honestly, this is not part of my role. It's the sensing part, and I have no detailed information about that. So, but well, maybe if this anonymous can contact me also anonymously or another way, I can find more information about this topic.
Yes. One thing I would like to ask everyone is please don't be shy, don't be anonymous. We are a group of friends here. Nobody's watching. Well, a few hundreds of people on YouTube, but that's it. I would like to ask now a few people in the room. But before you, Fernando, what kind of main challenges would you have that the ecosystem around Jena could help you with? Jena, Europe, the world. What kind of challenges you have for the people in the room today?
Well, the main challenge for us and what we are requiring to our partners is openness. Let's say we want to collaborate with partners. We are looking for partners. We are as you said in Jena, but we are part of a research center in Europe. So what we are trying is to collaborate and to move technology forward. In our case, our party is Huawei, but the thing is to create new items and to bring new ideas into the world. Doesn't matter coming from Huawei, from other, but the thing is to share together and well, I don't know. People are really shy to talk to us, and this is a good moment to say that we are open and we are eager to talk with anyone.
We have 65 people in the Zoom room at this moment, and 3 of them have told me they're going to contact you privately. So I believe that there is going to be a good room for those partners that they are here. You know, one company that I really wanted you to meet today is the company Plastic Omnium. And the reason for that is, I think many of you know the company Plastic Omnium. You are in the automotive sector, you know what they do, and you normally get quite a taste of the kind of things that they can actually do. But most important, I really wanted them to close the meeting and to tell us a vision for the future and how we can help them. I am very happy to welcome for the first time at these meetings, representing Plastic Omnium, Tejasvi. Thank you very much for being with us today. Tell us how we can help you. We're a group of friends, a community that can help you. Tell us your challenges and we'll do our best to satisfy them. The floor and the attention of everyone for the first time goes to Plastic Omnium, goes to you.
Thank you, Jos. So, am I audible?
Yes, you go to a slideshow mode. Yes, very good.
Great. So thanks for hosting this meeting. It's been very interesting and this is the first time and I'm really loving it. So I'm going to talk a little bit about the headlamps that we use and some of the critical challenges that we see in the development of headlamps. This is in general what a lighting system consists of, and something that we all know is that there is a huge transition or the revolution on each of these areas, and especially the current scenarios we see that the key change is happening in terms of the style and the optical concepts. We are having several technologies that are coming up to fulfill our the light demands, and especially in terms of the headlamp, the kind of transition that we see, it's remarkable. Just in maybe not less than a decade ago, the lamps have been several tens of millimeters, and the trend is going on into a slim or the ultra slim modes where even the customers are now interested to have something less than 10 millimeters. And this is not just for the signaling function, and I'm talking about the main functions like the low beam and high beam, which have a huge light demands. And so something interesting that is also is that although the sizes are reducing, the light demands from these small lamps is increasing, especially for the high beams, where we are talking about a minimum requirement of 120 lux of maximum, and a good amount of light on road, because you know these light on road is primarily driving the safety for the drivers, which is very important. And this was partly supported, we can say, by the kind of developments that we have in the LED. especially where now we have a better light demands or the light coming out from the LED. But that's not just the case. If we take a look at the kind of LEDs that we have on the market, so here are just one of the few points that we see are the critical in terms of the light distributions or in terms of the optical designs. And these are the kind of ratings that we put on a 5 scale. So the new LEDs that we have right now on the market, we have a good amount of variants and the power demands are good, but they are not quite enough to fulfill the higher light demands on the slim systems or the compact systems. And also, like we know that most of these, or we can say all of the LEDs follow the Lambert distribution. That's pretty good in terms of collecting a homogeneous light. But when it has to project the same onto the road and have a good amount of range as well as the width, this is not quite sufficient. And we do think that there is some room for improvement on this. And something most important with the new generation happening is we are talking about complex systems with higher powers or higher light demands, and that's coming at the cost of higher power consumptions. And that's not something that's really appreciated by the customers today. And the biggest problem beside of all these is the performances at higher temperatures. These headlamps, we usually do not operate it at a normal room temperature or at a moderate temperatures of 40. The operating temperatures in a very short span of time would increase to more than 60 degrees or 70 degrees Celsius. And that's really important. That's the biggest problem that we see. The light performance, it's really critical to have the stable light distribution or the light output at such higher temperatures. And something that is also important is the tolerances that we have with these LEDs. It's not so good enough. And the headlamp systems, especially systems like a low beam, are pretty sensitive to the positioning of the LEDs. So that makes our systems more compact. And not just these, something that makes our systems or the headlamp systems more critical is the kind of kinematics, the aiming schemes or the 3D shapes that we have. So what we, or maybe what we are trying to look at from this meeting or from the community is the possibility where we can customize the LEDs in a way that we have a totally different light distributions coming, maybe tailored to suit the specific functional demands. And particularly the biggest concern or the biggest demand would be in terms of improving the derating situation, which means the light performances at higher temperatures. And of course, it's also should be something that have a good kind of tolerances that we have, because at the end it's a physical part and we cannot really have an ideal situation. So I think with that, I would like to hand it over or book a discussion, start a discussion. If there is something that you could offer or some solutions that might work, that would really help us to improvise or improve the headlamp designs.
Thank you very much for us for the first time being here at the in this room. And of course, the challenge that you have there and the improve the rating is a material challenge. Are you working with non-material suppliers? Is there any material supplier that you are most interested in?
It's not just with the materials. It's not just with the materials, we can say. The kind of this performance is directly related to the LED system itself, because the LED in itself is very sensitive to the temperatures.
Mm-hmm.
So we know there are a couple of solutions that are in place happening in, and one way is to have this heat sinks and put in. But the moment we go for a high power LEDs and then we put in a high power light performances, the amount or the volumetric of the heatsink is going to be so big, and it doesn't really fit into our compact headlamps.
I know what the answer is going to be, but I'm going to ask anyway. They just be plastic or glass? Where do you stand?
Well, I think it's still with plastic because it's fairly flexible. We have several shapes, and I think that's where even the industry is looking at. It's mostly with the plastics that we use.
Are you sure? Let's make a round. Let's make a round. Let's see how it works. SUS Micro-Optics. Patrick, plastic or glass?
It depends.
Of course it does. It depends on what.
I mean, we do hybrid systems with combined plastic with glass. If we would have the plastics available for replacing the glass, we would go for full plastic. Currently, we don't have that solution on the market.
Let me see who has that solution in the market. Let's go to Hela. Let's go to Daniela. Daniela, plastic or glass?
A solution. But well, I have a comment on that. I think, as Patrick already mentioned, it depends on the use case, of course, but especially when we want to, collect as much light as possible. We heard that LED has a Lambertian characteristic. Then we need to go as close to the LED as possible with our optics. And then we get, again, a problem with the temperature, but this time for the material of the optics. And therefore, sometimes glass is, the best option when we have this high temperatures. But on the other hand, as we already heard, we have this high possibilities or this great range of possibilities concerning the shape, of course, only with plastics in a really, let's say, economical way.
Let me, because I want to hear the word of everyone. Ralph Knoll, Innoftech, plastic or glass? Where do you stand?
Well, we have producers for our lamps. We are not producing the lamps ourselves, but we work with an injection molding company, and of course the answer in that case would be plastic, because you can change the shape and you can mass produce basically. However, as all the speakers before me said, if temperature goes up, then of course you have to go to glass. So it really depends. I think there's no general answer, and as I said before, you can play some tricks with plastic, which you cannot do with glass. If you want to incorporate some ceramic particles, for example, for me-scattering effects, and then plastic is quite beautiful. You can play all sorts of tricks with plastic. But again, if the temperature goes up, you have to go towards glass.
I want to hear what Guglielmo has to say from Materion. Plastic or glass?
Sorry to repeat, it depends at the end. At the end, it depends. But what we see in general, it goes more to plastic than glass. And then, of course, one has to study if there is any other solution, basically to get rid of the heat and have some heat light separation coating functions in the systems.
Rolando.
If you ask me, I must say, I mean, by contract, glass. But on the other hand, I agree with Patrick and Daniela. Just like to add that, I mean, 3D shaping or freedom or freeform optics is not a problem for technology like ours, because actually we have an advantage with respect to, I would say, imprint. We are not 2.5D, we are fully 3D. The point that it remains is the mass volume production, which is not impossible to be done. It depends on volumes. It's a technology can be scaled also to volume production. And we are working currently in parallelizing a lot of processes, working on machines, optimizing the speed of processes. So in the future, it's also possible to have mass production with laser-based technologies. So if glass is the point, we can, and if people want to develop this at mass volume production, we can hit the target.
Daniela, from observing the industry for a few years, but mostly from observing what Hela and others have been doing, it does look like we are going to more customized, more direction of beams, more movable mirrors. And that is, for me, obvious that it has to be micro optics, it has to be micro optics, diffractive optical elements in them, and at the end it has to be made of glass. For me, there is no other way around that than that one. It's something that goes wrong there.
Again,
The
it
future,
depends.
not the
So,
today. I mean,
in the
price
future,
okay, but that's not what we're talking about.
well, for example, when I come back to the development of the flat light, I already mentioned in the presentation, when we look, for example, for optical stacks, and when we especially look, for example, for optics with a great or with a large surface that need to follow the car, contour the car body. Let's see which material it could be, but I think for some use cases, I think glass will be really fine, but especially for 3D curved elements or something like that, we have to see.
I believe that we are going to have a combination of both. I believe that we are going to have high-end lighting coming very close, very fast to the car. We're going to have directional beams coming tomorrow to the cars in most of the cars, and I think that's there's a huge future for the plastic, but also especially for the micro-optics revolution. I would like to thank everyone for being at the meeting today. It is being for me a quite enlightening meeting, but just remember, this is just the beginning. At this moment, what we want to do is to create a community. So the success of the meeting is not on the meeting itself, it's on the follow-up. So after the meeting, we're going to circulate with all of you the participant list, not just the people in the meeting, the entire participant list, all the people who register or people who can contribute with the topic. All we ask you is to have a look at it and let us know with whom you want to get in touch, because at the end of the day, that is what matters, that we all get in touch with each other. Until the next time, thank you very much for being with us. Again, Optica, my name is Jose Pozo. I'm here with Elise Fritz-Gage, with Alicia Jensen and the entire team. Thank you for making our job make sense. Thank you so much. Okay, so now I would like to ask Mary Wheeler to disconnect the YouTube. Please disconnect the YouTube. We don't want to be online anymore. So I believe that now we are not online anymore. So whatever we say just is, thank you very much. Recording stop. We are a private meeting right now. Jeremy from Magna, what do you think? What kind of challenges, what kind of ideas you have in mind after a meeting like this?
Oh, this is great. Yeah, thanks again for inviting me.